Hello guys, welcome. So today let's look at this question 100th digit from the Green Book. So the question states, what is the 100th digit to the right of the decimal point in the decimal representation of 1 plus root 2 to the power of 3000? So whenever we see a question like question mentioned in the form of a plus root b to the power something, and we are being asked like whatever we are being asked, the first thought should go to binomial theorem, because the if the question has stated that the format of the number as this, so there is a high chance that binomial theorem could be applied there. So anyways, let's look at this question. So 1 plus root 2 to the power of 3000. So here there is a very powerful hint given for this question, that 1 plus root 2 to the power of 2 plus this 1 minus root 2 to the power of 2 is equal to 6. What will happen to 1 minus root 2 to the power of 2n as n becomes larger? So let's try to first, so I'll just write the binomial representation of this 1 plus root 2 to the power of n. So it would be nck into 1 to the power n minus k into b to the power of k. Now this 1 would always be 1 no matter what the power is. So this essentially becomes nck times root 2 to the power of k. Now if we notice that when k is odd, so for nc1 this would be, so sorry, it will start from k is equal to 0. So for k is equal to 0 it will be nc0 into root 2 to the power of 0. For 1, similarly for 2, and for 3, and so on and so forth. If you notice that whenever k is even, then the term is an integer, and when it is odd, it is not an integer because of the presence of root 2. So if somehow we find a way to cancel out all the values which are non-integers, so how can we do that? We can do that by checking the binomial representation of the complement of the given value. So the complement would be 1 minus root 2 to the power of n. And if we see the binomial representation of this, it would be 1 ck, 1 to the power n minus k, and minus root 2 to the power of k. So here again, this would always be 1. And similarly, if we open this for k values from k starting from 0, it is nc0 into minus root 2 to the power 0. For 1, it would be nc1 minus root 2 to the power 1. For 2, nc2 into minus root 2 to the power 2, and so on and so forth. So here if we notice, here again for whenever the k is even, we get a term which is an integer. And lucky for us, whenever k is odd, not only that the integer is, it's not an integer, the value is also of a negative sign, which we can cancel the corresponding value, which we can cancel with the its complement's binomial representation. So if I just add these two values, 1 plus root 2 to the power n plus 1 minus root 2 to the power of n, all the values which are non-integers will get cancelled out because of the complementary sign, and we will get something, and all other values will have a factor of 2 behind them. And this would be 2 nc0 into root 2 to the power 0 plus nc2 root 2 square, and so on and so forth. And from this we realize that this value 1 plus root 2 to the power n is always an integer, because each term here is an integer, so sum will also be an integer. So how does this help us in solving this question? Now we are being asked, like, give the hundredth, or yeah, the hundred digit to the right of the decimal. So after decimal, the 100th digit, whatever it is, what is the value of that digit. So for n is equal to 3000, we will get something of some integer. So this value is an integer and we are adding something to an integer. Now, if you look at this number 1 minus root 2 to the power of 3000. So this number is what it will be. So root 2 is 1.414. So since it's a power is an even number, so the minus will all get cancelled out. And so it will be around 0.414 2 to the power of 3000. So if we just write it like 4.14 into 10 to the power minus 1 to the power 3000, and we see that there is a factor of 10 to the power minus 3000, and we can see that this is much clearly less than 10 to the power minus 100. So there is an integer value, and in that we are adding a value which is far less than 10 to the power minus 100. So the integer value will be something like this. Then after dot, let's write. So these are the 100 zeros, and the other value, the decimal value, would be which is far less than 100. Till here it would be all 0, 0, 0, 0, and somewhere far down the line there would be some value. Now no matter what the value is, it's a value x. When you will subtract it, so here if let's say this is all 0 and x, you can take x as anything. It's 2, 3, 4, anything. So if it's 4, 0 is 4, it is 6, and all the remaining values will be 9. So no matter what the x here is, it can be 6 or 7 or 8, it doesn't matter. All the values before it will become 9. And we are being asked, like, what is the 100th place value? So clearly the 100th place value would be 9. So in the solution, this has been just written, everything is written in one line. I just thought of explaining it so that in case if there is any confusion regarding how the author is coming to the conclusion that if 1 minus root 2 to the power 3000 is far less than 10 to the power minus 100, then how the last digit became 9. So just for that, I gave an explanation. So hope this was clear. Let me know if you have any doubt in the comments. I'll try to explain. Thank you.